Hi, I'm Rachel Mann, and my invention is the MedHelper, which is an autonomous medicine delivery robot. The third leading cause of error in hospitals is actually due to medical error. And my vision was to create a delivery robot, which I named MedHelper, which can transfer medical supplies reliably, efficiently, and punctually within the hospital environment. My solution was to integrate a three-wheeled vehicle, and it can carry medication and supplies up to 0.5 kilograms. There are three major steps in this. First, it deals with maneuvering. It can align with the hospital corridors and the environment. The second part is it can extract different information depending on the patient and the rooms. And the third part is communication, and it can communicate with the master computer in order to receive info and communicate effectively. So here is what it looks like. You can see it here. Here are the various microcontrollers being used within the system. And here's the schematic. You can see I have my main Arduino board connected to motor drivers with left and right motors, as well as ultrasonic sensors. I also have a 9-axis IMU, which I'm using for the gyroscope. I also have an RFID board connected to the bottom of the structure. And that's connected also to the 2.4 gigahertz wireless transceiver, the transmitter module. And on the master computer, I also have the receiver module connected to the computer. So the way I'm able to auto-adjust and automatically align my vehicle is through ultrasonic sensors. By sensing the distance between the nearest wall and the vehicle, it is able to automatically adjust and calibrate itself little by little. So if the motors are just a little bit off, it can readjust so that it goes in like a really straight line in order to stay in its own lane. I also use for maneuvering this 9-axis IMU. I have it used for the gyroscope. It's able to tell the change in the angle of the vehicle every single second, and I have a constant summation of this angle. So I'm able to tell where in angularly it is in comparison to the starting position, which is straight. So if I'm able to turn to the wall, it is able to calibrate itself like perfectly like 90 degrees in the wall and be able to manage itself automatically. So in here, this test, it's kind of dark. It is able to perfectly align with the corridor of the wall and go 90 degrees. I also have programmed an optimization of route. It basically attaches itself to the wall, and so it goes straight as a default, and also if the right wall isn't present, it turns right, and then in any other circumstance, it will turn left. So therefore, it'll attach itself basically to the right wall. And in this format, it's able to go in a perimeter-like manner, and it can browse the perimeter of every single, most of the major hospital corridors that you see within the hospital environment. I'm also utilizing the RFID tagging system. Now, it comes with a tag, like a scanner, and it reads the cards. So there's tags in our cards. And then I'm putting the tag on the bottom of the vehicle, and I'm placing the cards onto the ground. So when it goes over the cards, it's able to read the different information encoded on the cards. You can definitely change it depending on where you buy the cards. You're able to encode it with different information, and that can be changed depending on maybe the patient or the patient's room. It really depends. And it stores up to 2 kilobytes of data, and each one has a unique ID, so you can keep track of which card is which. For example, if you want to maybe attach one at a certain door, or you can keep it as a checkpoint, or put it near like an elevator so it doesn't go into the elevator, it's able to do that. This is much better than some other places which uses a QR code, because if you scan any place on the card, it's able to tell the UID and all the information, while the QR code has to match up exactly with the vehicle. So this is more flexible that way. As seen here, when the vehicle runs over the card, it is able to transmit the information here, and depending on which one it is, which card it is able to send different info. I'm also utilizing the 2.4 gigahertz wireless transceiver system in order to send and receive information, so you don't have to do the delivering yourself. You sit down at the computer and you receive all the data. So it utilizes two modules, the transmitter and the receiver. You attach one to the vehicle, you attach the second one to the master computer, and so when information is sent, or you can definitely program and set this, you can receive everything that is going on. So here are all the costs of all my modules. Most of all, I think it was the structure that cost the most, and this is way more I think it's way cheaper than any of the other delivery robots people have. I think most of the delivery robots have a GPS because they deliver outside, but it's harder in a hospital environment where you're inside and it's in a contained environment that needs to be flexible. So one of the other competitors could be Amazon Kiva. So the Amazon Kiva robots deliver based upon, the way you do it is you construct the route based upon tape on the floor, and the tape contains the QR code so that whenever the Amazon robot follows the QR code, it can go on this predestined path. The problem is that if you took one of these and you put it into another Amazon warehouse, it wouldn't know where to go, or you have to change the QR code, and that might be difficult. Or if you want to expand upon that warehouse, you need to reset every single part of the tape that's in each robot, and that's hard and takes a lot. However, my robot is very flexible and is able to peruse the perimeter of most hospital floors. Therefore, if you were to add to it, for example, you would be able to access that part of the floor without rerouting any of the previous tape if you had this kind of robot. Some of the additional features, like very small features I'd like to put on the robot would probably be like the buzzer, just as an indication of when it gets there, and also a force resistance sensor for to put on like specific medical weights, and if you it senses when you take the weight off.
The RFID cards again, can you explain that? It's meant to be kept on the floor instead of QR codes?
Yeah, it's like taped or attached to the floor, and when the reader runs over it, it's able to extract all the information on the card.
So could you also explain what was the most difficult or challenging part during the overall development or conception process?
So I think in general, it's really hard to assemble this many sensors together, and whenever you put a new one, everything just seems to fall apart, and you have to make sure that everything works well together. I think there were two ones that had to use this specific procedure, and I had to make sure they worked on the same line, and connecting it all together was very difficult.
All right.